Next up will be group by and also pivot table. And they behave slightly similarly to support different mental framework. You know, people coming from the SQL database training camp will be very familiar with SQL, the structured query language, use of the keywords group by, right? Group by. So this is definitely very aligned to that notion. And those people who are very much trained in using Excel will be definitely familiar with the idea of pivot table, right? So why don't you create a pivot table and pivoting on this column and so on. So Pandas supports both no, not ideologies, but ways of thinking about analyzing the data. So the end result is I'm going to show you pretty much the same. It's just how you think about processing, flow the data in certain ways. So let's begin by group by. Now, don't memorize any of these. I would suggest you don't try to memorize this. Think of group by. Now, even if you don't have SQL background, don't worry. Group by is just but extracting out the unique values that you supply as the column name here. So for example, I say group all the rows, all right, by this column's unique values, A. Now, what are the unique values? We have analyzed it ourselves before, right? We have done this value counts and all that before. So we can say group by, it does a value counts, it performs the unique values XYZ, right? So it has this idea. And you can imagine all the rows, X368, X341, X123, X937. All these 4 rows are grouped together inside this function group by. And then group by doesn't end there, right? We never just call df9.group by quote A unquote full stop. We'll never do that. If you do that, it will return to you a semi-function thing. It's like a little lambda there sitting there. It's not useful to us. We have to continue because whenever we group by, the rows are grouped by the unique values of this column. So all the x's are there, y's are there, z are there. But that's it. It's semi-done kind of thing. Nothing has come out yet. We need to continue to eventually supply an aggregation function. Remember what's aggregation function? An aggregation function like mean will take in a lot of numbers and churn out one number, sort of like a summary of all the numbers. While average tends to be quite natural as a summary, we also allow for size. That means how many times did the rows occur in having x as its a values. So we will have 4, right? How many times for y? 1, 2. So the count of the number of rows having this unique value in A is also summarizing many numbers into one. Then we have obviously min, max, standard deviation, median, mean, and all the statistical functions are by and large aggregation function. So what this means is calculate the mean. Of course, for mean, we need a column. So we say calculate the mean of C. So we say group by A. So all the rows are now sorted by kind of unique values of A. Then we extract only column C, all right, and then calculate the average for only those rows with X, only those rows with Y, and only those rows with Z. For example, Z, we only have 1 row. And for C, the average of 6 is 6. So it's not average of all values in C, but grouped by, that's why its name is saying, grouped by X, Y, and Z. So it's not surprising that we get 3 rows only and having only 1 C because we ask for it. What if we want average of all the columns? Then do so, right? So dot mean of all the columns, and if some of the columns other than A are string types, they will be skipped. Just like sum will skip over non-numerical values as well. So dot mean will return all the columns because no specific columns have been mentioned. Okay. Now, suppose we want only B and C, B and C. We can always calculate for everything and then select B and C from the rest using .log LOC, right? Remember? So we can always do that. So very, very versatile, and definitely in uh, in my experience, most useful applications. All right, useful means it does some smart work for the user. It performs many important calculations and decisions and whatever it is for the user. Most such applications tend to invoke use of group by because it really looks at individual categories and analyze them separately rather than lumping the whole column, irregardless of um, the various unique values. Now, the way I say unique values might sound a bit too distant. So in practice, this is a bit like, um, oh, the average income of Singapore is 60,000. I don't know, but let's see. But that's a bit too broad, right? That's ignoring certain um, demographic profiles. So we want to break it down, right? So what is the average income for Singapore citizens? What is the average income for Singapore permanent residents? And so on, right? So we can then do, and then these average values grouped by the residential status will become more and more interesting because they're more and more focused, more and more targeted. Okay. What if I want to say, what is the average income grouped by residential status and within it, male and female? So we'll have Singapore citizen male, Singapore citizen female, Singapore permanent resident male, Singapore permanent resident female, foreigner male, foreigner female. Okay, so these three. So I have two columns, right? Because it's residential status versus gender. And I like to analyze that for social analysis or whatever. Can I group by more than one column? Answer is yes, you can do that. Okay, so instead of saying A, you put in a list of A and B, column A, comma, column C, up to you. So very powerful, and with just one additional input, you get to do crazily deep, demographic analysis. So really, definitely use that. And so when it comes to pivot table, just another form of talking about group by. But then, of course, the thinking for some of us, very whose day to day is always revolving around Excel and pivot table, pivot charts, then this is great, right? Because you have minimum learning curve. But then, of course, then your learning is in how to think also about group by because it allows you to think about the data from another perspective. But notice that the outcome is the same, especially on the right side here. Okay, so let's take a look. So for pivot table, I'm using back this table here. We get to see that for pivot table, we can say pivot against, all right, pivot against column A. It says columns, but it allows for one column. So pivot against column A. I think we should remove this column here. So pivot against column A. Let me cross it out because otherwise we should see column another row here for E. But doesn't matter. You understand what it means. So when we ask for this, the pivot table column base pivoting on columns A and having the values taken from B, C, and D. Oh, yeah. So this E is sort of excuse not participating in the computation, right? Then we find that the result is going to be this, where the unique values are now listed in the columns, which is great because then we can say DF9PA, this outcome, dot little x. Remember, that's a convenience that we can enjoy in pandas. So when we put it this way, the values that we listed, B, C, and D, are now listed as rows. So in other words, the columns are our sort of main access points because we can dot x, dot y, dot z. But that is not really the point. The point is that for us who are used to thinking about pivot table, it will summarize the unique values for A. We are not new to this, right? But it will summarize it in the columns and then put the values below. Okay, but remember that the content here, what are these, right? In Excel, if you don't put anything, you will see a pivot table that's nothing, blank, ready for you to modify further. But when we get a pivot table and run it, we will get back, first of all, a data frame. Secondly, the content is not empty, but having some values that is basically the average. So pivot table actually is just like group by. It also requires an aggregation function. And if one is not supplied, then the default value is going to be np.me, which is to calculate the average of these listed columns, right? So B, C, and D, so across. Compared to previous group by, right, the pivot table is similar, except results are transposed. Let's look at this one, right? We grouped by A earlier on, and we saw that the XYZs are listed below, and the BCDs are listed in the columns. But the answers are the same if we use a .me. So this aggregation function is really very explicit. We can see it here. For pivot table, we don't see the default aggregation function, but it is there. It is there. So pivot table is just another way of thinking about group by to minimize learning curve for some of us. Okay, but if we change the nature, we use index. Okay, so it's a bit like dragging A in Excel, whether you drag it to column to list out the unique values or to drag it into rows to list the unique values. So if we do it here, all right, then this time round, the results is transposed for pivot table the other way around. So when we do it this way, compared to pivot table earlier on, the answer is exactly the same, like this. So this is group by, this is pivot table. I purposely have it fixed to the same spot in both slides, so you see that it's hardly changed at all. And in fact, that is the whole point. Pivot table is just group by, sort of mentally thought about in another way. So for some of us used to pivot table in Excel, this is great. For some of us coming from SQL Cam, use group by. So both ways can do the same. Okay, great. So that sums up pretty much our exposition to the statistical set of functions and methods provided by pandas to analyze our data frames. Next, join me in the next video. We'll revise and explore all these functions in the real Python lab, right? So see you in the next video.